Hi there, PyCon 2020. Thank you for joining me for this talk, Introduction to Writing Network Tests with pyATS. My name is Hank Preston, and I'm a network automation engineer and developer with Cisco DevNet, and I'm also a NetDevOps enthusiast, excited about any opportunity to talk about modernizing network engineering and automation using Python and other tools. In today's talk, we're going to kind of tackle ourselves through a handful of agenda points. We're going to start out with an understanding of exactly what is pyATS and what is the problem it's trying to solve. We're then going to kind of dissect what goes into a network test project. Specifically, how do we develop a network test bed and describe our device connections? We're then going to look at the anatomy of a test case and then how we can combine multiple test cases into an individual test job. And then finally, we're going to end with a demonstration of how we can use pyATS to test whether our network is working as expected. So first, what exactly is pyATS? Now before we answer that, let's pose the age-old question. Is the network down? Now whether you're a network engineer or network automation engineer, or just a software developer that leverages the network that your network engineers go through, you've probably found yourself in this space. Something just doesn't seem right and you're trying to figure out, is it the network? And you might go up to your network engineering folks and say, hey, is that network down? And you get these blank stares and they're not sure exactly how to answer that because the network has got all of these pieces that are there, and how do you troubleshoot it? And so the thought process often comes into something like this. So what exactly do we check? Nobody's sure. And then oftentimes we come back to the age-old kind of main network test functionality tooling that we have today, which is ping, right? So somebody suggests, can you ping it? And we have to wonder, is there a better way? Because ping, while important, right, to establish connectivity, doesn't answer questions about whether you're having latency, traffic selection problems, whether there's actually congestion on links, whether traffic is following the flow that you expect it to, right? Ping is just one small part of whether the network is actually functioning as expected. And this is where pyATS and the pyATS library come in, along with the ecosystem that comes around it. Now, the idea here is to build a modernized platform and framework where we can actually write good, solid network test cases to see, is the network functioning as we want it to and as expected? Now, the pyATS ecosystem and systems that are the portions of the pyATS ecosystem that are out there are released and available under the Apache license version 2.0. So you can get access to the source code, contribute back to many elements of the ecosystem we're going to talk about so that everybody can kind of help all across our fellow users tackle the network test problems that are there. Now let's dive into exactly what makes up the pyATS ecosystem. Now at its base, we have what we call the pyATS core test infrastructure. This is actually what is often meant by the pyATS library components themselves. These are how we describe topologies, the test definitions, how we track the execution of tests, gather results, develop logs, and report back on those pieces. Even send out email notifications if we configure that as part of our core test pieces. The pyATS core test for infrastructure actually doesn't have a lot of direct connectivity into the specific things you want to test in your network. It's kind of the framework necessary to run these tests as they go through. On top of that core test infrastructure, we get the SDK in the library, the pyATS library. Now, it was often previously referred to as the Genie libraries that were in there, and you'll see this name pop up in different places. And what the library offers is a kind of a reusable components that can be plugged in and run against your network to go through. This gives us the way to say, okay, I'm interested in the state of, let's say, a routing protocol like BGP or OSPF. By using the pyATS library capabilities, we can very easily in Python ask the network and network devices, what's the operational or configuration state of these different portions of the network? We don't have to worry about kind of parsing through clear text information or trying to normalize data between platforms. All of that is handled by the pyATS library itself. In addition to that, we get kind of a building blocks of different testing components and triggers and validations that are included with the framework itself. And then on top of the SDK and library is where business logic and integrations can be plugged in. Many teams are looking at how we can tie network testing into larger test frameworks and CI/CD pipelines. And so there's areas where we can use pyATS ecosystem to plug into Jenkins tool systems, other CLI examples, frameworks like Robot, or tie into infrastructure as code solutions from Ansible and other areas. And so the pyATS ecosystem is this entire kind of combination as it goes in. In today's talk, we're going to focus kind of in that core test infrastructure. How do we connect to our network, and how do we write and articulate our test cases themselves? Now, where do you get pyATS from? Like any good Python program, it's available up on PyPy, so you can pip install pyATS to pull down all of the bits from PyPy. Now, it does require Linux or Mac OS to function, but if you're a Windows user, we can support it inside of Docker or virtual machines as they go through. So you can actually pull from the Cisco Test Automation an available latest Docker container that has everything necessary to run your pyATS use cases inside of there. Now, as of a few versions, we have upped and removed kind of Python 2 support, and we do recommend Python 3.5 or ahead or greater to leverage all of the Python pieces that or to leverage the pyATS ecosystem and framework that's in place. Now, a couple of reference pieces. Even in this display that we see on this area, we can see that we've got version information, libraries called Genie, pyATS, and Unicon. And these kind of correlate back to that pyramid that we saw a few slides ago. The pyATS Python libraries tie back to that core test infrastructure. This is for connecting and running those tests as they go through. The Genie, these are the libraries of the pyATS library, and it's composed of reusable models, triggers, parsers, verifications, a whole suite of APIs that you can use to talk to and manipulate your network devices that are out there. And then finally, we have the Unicon, or the Universal Connector libraries. These are kind of rarely called explicitly in your code, but rather get leveraged by the pyATS library or the pyATS core. And this is how we actually handle the independent connection or consistent connection to devices, whether we're connecting over Telnet, SSH, through terminal servers or proxies, or using protocols like HTTP or netconf area. And so as you see those imports in the libraries, again, Unicon, Universal Connector, kind of under the hood, pyATS are kind of the core test framework areas, and then the Genie is that pyATS library full of all the good components that we can use in our code. Now, with that out of the way, let's talk about what goes into an actual network test project. Now, a lot can go into it, but from a bare minimum, we really only need 3 different components. First, we need a description of what is the network that we're talking to. And this is referred to as the testbed file, or testbed.yaml, though you can name it anything you want. Often they're just referred to as testbed. And inside of that YAML file, this is what describes our network topology. What are the devices that we want to talk to? What are their platforms? What are the connection details? What are the ports? Is it Telnet? Is it SSH? What are the credentials that we use to go through? All of that is handled as part of the testbed.yaml file. Next, we have the AE test scripts, or the automation easy testing test scripts. And these are going to be 1 or more Python files that describe the setup, execution, and cleanup of individual tests that you want to run. And you can have multiple of these that you would execute against your network, tackling different pieces. Maybe you have an AE test script that goes and checks that devices are just up and functioning. And then you have another one that tackles things like layer 2 connectivity checks and layer 2 configuration. And then we move up to layer 3 and routing protocol verifications. Each one of those may be broken off into a separate AE test script. And then finally, we have the EasyPy job files. It's in the job file where we actually combine together the test bed that describes the network we want to verify with the test scripts that we want to run against those to go in. And the test job kind of handles running all of those kind of as an instance and then reporting back the results in consumable fashions as they go through. Now, to help with the configuration and setup of all of these components, there are convenience commands built into the pyATS CLI that comes when you pip install pyATS. Pip pyATS create testbed will help you frame up your testbed file. You can build this either by hand in YAML, you can import and kind of convert from a CSV or Excel spreadsheet, or you can just answer questions at the command line and it will construct the YAML file for you as a starting point. And then pyATS create project will kind of give you templates and cookie cutter places to start related to your job files as well as your test scripts as they go in. Now let's jump through each one of these three components to take a look deeper. Now first, we have our pyATS testbed. As I mentioned, this is going to define all of the devices in the network. Now we have a variety of types that you may have inside of your testbed. You'll have switches, routers, firewalls, but you may also have kind of Linux end hosts that you could use as part of your test execution for traffic generation or just verifying that the network is functioning as expected. Now each device will also have to be tied to platform and operating system. Now clearly the pyATS platform will support the operating systems from the different Cisco networking platforms such as iOS XE, NXOS, ASA, but we also support operating systems like Linux for those hosts or even other vendors such as Junos and F5. These are all operating systems supported by the pyATS framework and ecosystem that's in there. Now, in addition to the devices themselves, we have to know how are we going to connect to the devices. Unicon supports connections over SSH or Telnet, Netconf, different capabilities that go through, as well as support requirements if we have to go through a terminal server or proxy server as well. That can all be described inside of the testbed. Now, and you also have the option inside of your testbed to describe links. How are the interfaces connected between all of these devices? That's not mandatory, but for more advanced testing, you can actually describe kind of the intended source of truth for how the network is supposed to be set up, and then verify operational state against those as they go in. Now, as mentioned, the next piece are the AE test scripts. Now, a test script is a Python file, and if you've written test scripts using PyTest or other test libraries, there's going to be some similarities here. We're going to have three phases to every test script. Phase 1, common setup. Everything necessary to do before you begin running your actual tests that are there. This is a common place where we would use our test bed and actually go out and connect to each of the devices that are there. Then we have our phase 2, which are the test case or cases. Any AE test script could have one or more tests that are going to go ahead and get run as they go through. And then finally we have phase 3, which is the common cleanup. Now you'll notice the way we describe what these components are, or which phase they go into, is by extending out aetest.commonSetup for the common setup component, aetest.testCase for a class that's going to be an actual test case, and then aetest common cleanup will describe where is your cleanup step to go through. Now inside of a test, you may have sub-setup and cleanup steps as well, depending on the requirements for those tests. But as you can see here, test case 01 does not have the setup and cleanup phases put in, while the test case 02 does have a setup and cleanup. And then inside of each test case class, we can have any number of decorated aetest.tests to indicate how we're going to pass through as they go in. Now in this slide example, we can see that we're just passing on each one of these tests to show the framework. We'll see examples of that as we get into the demonstration of what a test may actually look like as they go in. But because it's Python, anything you can do in Python can be done inside your test script. Then we come to the job file. Remember, we can set up any number of test scripts that we want to run as part of our actual network validation. And inside of the job file is another Python file that just brings together all of the test scripts that we want to run as part of an individual job. And so we could have test scripts written for multiple projects and then pull together into single job files to run against different network components that are there. And we can see here these Python scripts are often quite simple and short. We simply go through and we execute the run from the EasyPy library against each of the test scripts that we want. Now the task ID here that I've specified on the slide is used as part of the logging and notification pieces as they go in. If you don't provide a specific task ID, the pyATS libraries under the hood will just kind of indicate the task and then a number as they go in. But for complicated test jobs, you probably want to give a name so that you understand what each one of these test scripts was trying to accomplish as they go through. Now with those three components in place, then we can go ahead and run our job by using pyATS run job and then you give it the job file and the test bed that you want to combine together, or that you want to pull together to run for this execution. And then you'll see in the display, it comes through and says, okay, for each one of the tasks and each one of the tests, did we pass, or other options might be skipped, failed, or errored. Now here we've just got a basic bootstrapped piece, so there wasn't a lot that went through, but your actual test can have lots of detail and data, lots of output displayed at the CLI. Now you'll notice down here at the bottom, there's this little pro tip that pops up. Even for small, simplified network tests that you may run, there's a lot of data that can come out at you at standard out. And just kind of parsing through that, looking through that in one large blob can be difficult to kind of figure out what worked, what didn't work, or find issues that are there. But with the pyATS logs view, what we end up doing is automatically kind of showing you an HTML view of the logs from this job run that you can kind of drill into as it goes in. Now here we can see kind of the main dashboard that gives you the bar chart, key details around this last job run. And then we can jump into the individual tasks that were run as part of the job. Here we can see task 1. If I go ahead and click on that, it'll bring up the actual task detail, and we would see each test across that task and whether it succeeded, passed, failed, all of the status. Now suppose we wanted to see the detail for a particular step out of the task. Well, we can simply click on that step and see all of the actual output that was gathered by pyATS when it ran these tests as they went through. And so here we can see the kind of the standard output that's captured. Now this output's the same as what we would see kind of at the CLI terminal when we execute it. This is just a much nicer way to kind of view and look at it. Now with the basics underway, let's actually see this in action in a real live network test demonstration. Now for our demonstration here, we're going to be running against a network that looks like what we have up here on the drawing. So we have a fairly common 3-tier type of a network with a access distribution layer, a distribution router, a couple of core routers, and then off to an internet through a firewall as it went in. We've got some basic routing protocols configured, interfaces, and traffic flow as it goes in. And this is a sample network that's provided by DevNet Sandbox. And so here's one of the best parts of this demonstration is if you want to try it yourself, all the code for this demonstration, as well as the environment necessary to run this test, are all available up on GitHub and then provided by DevNet Sandbox. Links available here in these slides. We've got a QR code at the end so you can find the slides themselves. Now our goals for our test job that we're going to run, step 1. We want to verify that each and every device inside of this test bed is reachable. That's our first test. Can we talk to all of our switches, routers, firewalls, and other devices? Our second test, I want to verify that there's no interface errors on any of these connected interfaces. Now, what do I mean by that? One of the most troublesome things to troubleshoot inside of any network engineer's kind of day is if somebody comes through and says, I'm having performance issues on the network. It's not that the network hosts are down. Those are frankly fairly easy to figure out and fix. But no, the hosts just they're performing slower than expected. Or maybe some of the applications are going up and down. Now there's lots of things that could potentially cause that. But one of the things we often look for is every hop along the way or every portion of the network that's relevant, are we reporting any errors? Are we reporting CRC errors? Are we reporting jumbo frames that are getting dropped? Are we reporting malformed packets, input-output errors? And it can be very time consuming to gather all of that detail from across the entire environment. And so what I want to do in our test here is to actually verify across my entire network that we don't have interface errors being reported. Because in general, in a healthy network, we shouldn't see interface errors, right? So I want a very quick way, can we go and look, do we have any interface errors that are out there? Okay, with that, we're going to jump into the live demonstration and see this in action. All right, for our demonstration, here's the network that we're going to be using. As mentioned, this is being provided by a DevNet Sandbox that you could reserve of your own to give it a try. But what we have here is our network display that's in place. And so for example, I've got my routing tiers here, and we can do like a show IP route and see that we've got routing traffic that's been learned as it goes through. And inside of our network, we have some Linux hosts. So down here, I have inside host 01, and then outside, I've got an internet host 01. So let's see if the network traffic is functioning across the network as it goes through. So is this network, does it seem to be operating? So if I do an SSH and I try to just connect from the inside host to the internet, Cisco at 172.31.0.11, we can see that indeed I was able to SSH and connect to the internet host. And so this shows us that the network is at least functioning to some level. I'm able to get from the inside host through the switching layer, the routing layer, the core routing layer, through an edge switch, out through the firewall, through the internet router, and then finally to the internet host. So traffic paths are functioning. But let's actually run our network verification to see if there's any problems in our network as it goes through. Now we start out with that testbed file. So this is a testbed that describes our network that's out there. And so we can see our internet routers here. It's an iOS XE device. We can see the internet hosts. This is a Linux piece. And then up at the top, if you'll notice that we have shared kind of default credentials to use across the board. And our testbed supports inside of pyATS the ability to pull credentials from multiple locations. You could put them in clear text in your testbed, not recommended. You can do what I've got done here, which is where we're pulling them out of environment variables, a little bit better from a security perspective. But we also have plugins for encryption and then to pull this information out of solutions like a Vault solution as well. In this case, I'm using environment variables, and then I have an environment file here where I just kind of set them to the default Cisco username and password that we're using in the environment. And so for that, I'm going to jump here down to the terminal, and I'm going to go ahead and just source out pyATS env to set those environment variables, and then we're going to go ahead and we will run our test job. So pyATS run job, and then we're going to run network test project, network test job, and then we're going to target at that test bed that we went through. So we'll go ahead and we'll run this and see what happens. Now during this execution, kind of as this flies by, what we're seeing is kind of right now Unicon connecting to every single one of the devices and establishing and verifying that it can actually talk to them and execute commands and gather information. And then it's going to the pyATS test scripts will run to actually verify all of the test cases that I've described that I want to kind of run through and get and see if things are healthy. Part of that includes actually gathering information about every interface on the entire network. And so what we're seeing here in standard out is kind of all of the logged information that's being captured by pyATS using the different elements of the library components and the logging components to gather and process all that data. And then it runs through the test scripts to see kind of what passed, what failed. And there'll be kind of summary information once this fully completes down here at the bottom, which should be coming up here in just a second. I saw some red text fly past me, which tells me that something must have gone. All right, so here we've gotten to the end, and we're going to do this pyATS logs view in just a second. But what do we see kind of in the CLI? Now from our test case, we saw the network that was there, and I'm checking every interface that's in place. And so we can see these steps that go through for each interface that's being verified. In this case, the one I highlighted, this one passed. But down here, step 8, where it looked at for interface errors on edge switch 01, well, that overall step failed. And I can look kind of by the interface levels and see I got lots of failures in place here. If I were to scroll up, I'd be able to see kind of the points in time during the test when those interfaces were checked. But that's a lot to do kind of at the terminal. So let's go ahead and use the HTML log viewer built in. So pyATS logs view. This will start a Python kind of web server and then host off the actual log files for us to take a look at. So the pyATS logs view opens up my HTML piece here, and I get some statistics and information. We can see that there were a total of 6 tests, 5 of them passed, 1 of them failed. And I can go through and see details. Up here at the top, we can see I ran 2 test scripts. The first one was device connections. If I look at this, everything shows passed. So this tells me I was able to connect successfully to every single one of the devices. Now, if I wanted to see kind of what happened during each of these phases, let's say one of the devices couldn't be connected, I could click on one of these tests and get all of that standard output, all of the information that was logged kind of at my fingertips and ready to use. But in this case, device connections didn't have any issues, but interface errors, here's where we saw some problems. And so we can see the common setup, that passed, loading the test bed was fine, connecting the devices, that was all fine. But the overall interface errors test case did have some issues. We can see here the test itself failed, but each one of the devices and each interface on a device kind of gets reported independently as they go through. And it's up to your test script definition to figure out kind of where the inheritance of failures happen. But in this case, if any interface fails, we would have kind of marked the entire test as failed. Now, rather than kind of scroll through, I'm going to go ahead and sort this by the results to bring the failed all up to the top. And we can see here, Edge Switch 01, each of the interfaces failed. If I click on one of these, we can say, okay, Gigabit Ethernet 2, and we can see, okay, checking the interface, checking status of Internet Gigabit Ethernet 02 has failed. And if I look at the line above it, we can see I get a failed reason that gets noted. And it's because Gigabit Ethernet 02 has a count of 3 for in errors, which is one of the counters. If I go back and I say, okay, well, what about some of these other interfaces? Gigabit Ethernet 01, we can see it also failed. It also had a count of 3 for in errors as they went in. And so now I can see, okay, there's some problems, or it looks like there might be some problems on this particular edge switch in these interfaces. In general, again, we don't want to see interface errors. But as I'm looking at this and trying to debug it as a network testing developer, I realize, what are the other counters on this interface? It'd be nice to kind of understand some more context in this log to help troubleshoot it. So let's update our test cases and see if we can make some changes to learn about the full status of the counters that are there. So I'm going to flip back over here. And so now we're going to look at the actual interface errors.py test case. And the part I want to point out here is we're going to look at this portion of the test. So here we've got our definition of the test. And we're going to go through and we're going to talk a bit about kind of the layout here. But it's just basic Python. We've got some for loops. We've got some context handlers in place. But because it's just Python, I'm going to go ahead and uncomment out this line that I put in for the demonstration to show that in addition to just logging kind of the status, whether we passed or failed, I want to do a log of an info and actually log out the full information about all of the counters for an interface so that I can see that inside of my log information that's there. So simply, I'm just uncommenting this new logger.info line. We'll go ahead and save that update. And then I'm going to go ahead and rerun my test cases so that we can kind of see if we get more information inside of the run. I'm rerunning the exact same job file. It's now just going to connect back out and run using the updated script that I processed. So this will take, I don't know, 90 seconds here to run against the entire network. All right, the job finished, and if as you were watching it go through, you may have noticed kind of additional data kind of in JSON format flowing through. But rather than try to look at that in the CLI output, let's actually take a look and rerun that HTML logs viewer for us. All right, so here we're back. We're looking at the latest logs. We'll jump back into interface errors. We'll resort by result, and now we'll look at one of our interfaces. And now we can see what we saw before. With step 8.2, we can see it failed. We can see count of 3 for in errors. But now we have this new line also logged for each interface. Shows us, well, how many packets did we have? We'd had 990 packets came in. We've had so many octets. We can see the broadcast counts. And so now, as we're troubleshooting this network issue, I've got more context. I know what the overall kind of counter status and usability of this interface is. And so I can use that to make a judgment call about what I do next. All right, with that, that kind of finishes the live demo. Let's jump back to the slides and kind of talk a bit more about some of the code pieces that were used here. Now, I don't want to do a full code walk. You can take a look at the Python code from up on GitHub with the link that's there, but I do want to highlight a few key elements that are part of writing the tests. And so here we're going to start with the connection verification test. Some keys that we see in here is that we have the ability to kind of use steps as part of an overall test. And we saw that in the demonstration with step 1, 2, 3 for each one of the devices, and then step 1.1, 1.2 for kind of sub-steps for individual interfaces. And so pyATS, the core infrastructure as part of the testing, gives us this concept of steps that can be used inside of a context handler. And so here we've got with steps.start, and then we can give it kind of some details about the name of this step. and then we can kind of process some bits and pieces inside. And then at the end of this step, we can determine whether we want to fail based on some condition. Here we're checking to see if the device is connected, so device.connected, true, false. If it's true, the default status of a step will be pass. But if it's anything other than true, we want to go ahead and mark this step as failed. And it's that simple to indicate whether a test, an element of your test fails or passes. In addition to failed status, there's also errored, pass X if we're just going to kind of pass something, but there's some exception we were running through on it. Or maybe you're going to skip something for a particular reason. All these options exist. And then if we look at the interface errors, we can see here where we're using the setup step to actually go ahead and kind of learn details about the interface. Now remember, in the pyATS ecosystem, we've got the pyATS core libraries, or the core pyATS. Then we have the Genie library, or pyATS library, that comes with all the models and parsers. And here's where we can see that we're leveraging that. Device.learn. Learn is a function from the pyATS library where we're saying just go learn about the interfaces for a device. Now, no matter what type of device it is, this model, that pyATS library model about interface concepts, knows what commands to run, knows how to parse that data back into a Python dictionary that can be used for very easily understanding the health of particular network pieces. And that's the magic behind the pyATS library component of the overall ecosystem, is it removes that necessity for the individual developers to write the regex or learn how to kind of parse that clear text data that comes in as it goes through. Now, still on the interface error test, here we can see an example where we've got nested loops. So we start off with here with the blue for each device. So for every device in the kind of the test bed as it goes in, we're going to go ahead and we're going to loop over the interfaces, each one of the interfaces that are inside of those devices here in the green. And then finally, there are several counters that an interface might have. We saw in the demonstration that there's in counters and out counters and errors. Well, we set inside of our code a particular set of counters that we're interested in checking. And so we're going to go ahead and say, okay, let's go ahead and look for every counter that we've indicated as an error counter we're interested in, and then go see, is that interface, is the length of the counter greater than 0? Is the count greater than 0? If so, we're going to go ahead and mark that step as failed. If there aren't counters at all, we're going to go ahead and mark that step as skipped. Where is it here? If there are no counters on an interface, we're going to skip this step. Because there are some network devices and interfaces, such as loopbacks or VLAN interfaces, that may not have counters attached to them. We don't want to fail a test just because there were no counters, so we'll mark that as skipped and kind of give the information that's there. So that's just a quick look at kind of some of the pieces that we can do inside of the Python as we write these tests. But a reminder, all this code is available up on GitHub to look at. Now, in summary, kind of where can we go from here? Now, I've only been able to kind of scratch the surface of what's possible with pyATS ecosystem. There's so much more that's out there for you. And we've gathered up a lot of resources that you can take advantage of to dive deeper into network validation testing with pyATS. You can look at the pyATS homepage, you can read the Getting Started guide, you can explore the code on GitHub or PyPy. You can also kind of join the community inside of WebEx Teams, which is a chat program similar to Slack, but it's a Cisco kind of collaboration platform where the community, as well as the developers of pyATS and the libraries and all of the integrations, are helping users with both getting started level questions as well as advanced integration questions. It's an excellent place if you're interested in network validation. Also on this slide, you can see a QR code for where you can download these slides as well if you want to kind of dive deeper into them and get access to some of these links themselves as they go through. Now, in final closing, if you're interested in network automation, I encourage you to stay in touch with me as well as the rest of our team at Cisco DevNet. You can follow me on Twitter at HFPreston or reach me on email or WebEx Teams at hapresto@cisco.com. And then be sure to follow Cisco DevNet everywhere that you can follow anybody these days on social media. With that, thank you so much for joining me today for this PyCon talk. I hope you've enjoyed it, and I'll see you next year. Bye-bye.